have an equation. Because sodium is more reactive than hydrogen, it is going to displace hydrogen from that compound. So you have sodium chloride plus hydrogen gas. Which element is oxidized, which one is reduced? So we can use their oxidation state to know. Sodium here is 0. Now combined state, oxidation state of an element is what? 0. For sodium to form this sodium chloride, it means that it has lost an electron to chlorine. Based on ionic bonding, sodium has lost an electron to chlorine. So that is why the state of sodium in this sodium chloride is sodium plus, and chlorine is chlorine minus, because chlorine has gained electron. In chemistry, if you get an atom gain electron, it becomes negatively charged. If an atom loses electron, it becomes positively charged. Okay, so sodium has moved from 0 to +1 in this compound. Okay, now what about chlorine? Chlorine does not change. Chlorine is still -1 here. In this compound, chlorine is still -1 and hydrogen is +1. So chlorine remains unchanged. It does not undergo oxidation nor reduction. But now let's look at hydrogen. In this place now, hydrogen to here, hydrogen has been reduced. How? It is +1 here. How do I know that it's +1? Hydrogen is +1 in most compound, except it is reacting with a metal. In hydride, that is when we have -1. In hydride, hydrogen is minus, the oxidation state of hydrogen in hydride is -1. But this is not an hydride. Hydride is when hydrogen form compound with a metal. So in this place now, in this hydrogen chloride, hydrogen oxidation state is +1. Okay, it is +1. Let me use it. It is +1, and here, so the oxidation state of uncombined elements in their free state is 0. So it has moved from +1 to 0, which is reduction, because there's a decrease in oxidation number. So in this equation, in this reaction, sodium has been oxidized. It has lost an electron to chlorine. Chlorine remains the way it is because it doesn't change state. Chlorine does not change state. It's still that -1 here, and it's still -1 here. But hydrogen is the one that changed state, changed the oxidation state from +1 here to 0. So hydrogen has been reduced, while sodium has been oxidized based on oxidation and reduction based on the increase in oxidation number or decrease in oxidation number. We can say that sodium has been oxidized in this reaction and hydrogen has been reduced. So in this case, we call chlorine spectator ion because it is neither reduced or oxidized. So if you are to write the ionic equation, we are not going to include chlorine because chlorine is called a spectator ion. The oxidation state does not change. So to write the ionic equation, we'll write for oxidation. For oxidation, we'll have for sodium, that will be Na plus E minus. So for reduction, for hydrogen, we'll have H plus is gaining electron, okay, to give you hydrogen gas. This is 2, so we are going to balance it and put 2 here. because everything has to be balanced in chemistry. You must balance your work so that the charges will balance out. So because we have two atoms of hydrogen here, that means we will have two ions of hydrogen ion, and each of these ions will gain one electron each. So that is why we have two E here. That will give us hydrogen gas. Okay, so this reduction ionic equation and oxidation ionic equation. So any spectator ion will not be shown in the ionic equation because their oxidation state remains unchanged.